So what we wrote an important sentence in the previous section. We said every investor will have a different capital allocation line. So doing a quick review of what we have been looking at so far. Don't write this, just understand. This is minimum variance frontier. This was built using an optimization software where we defined what is that portfolio for given level of return will have lowest possible standard deviation. Then this part of the minimum variance frontier is called efficient frontier. Then once we have efficient frontier, we superimpose indifference curve, and that point where indifference curve is tangent to efficient frontier, that was your optimum portfolio for the client. Then that optimum portfolio added along with a RFR produced capital allocation line. Okay. Now next graph in the series is, so if you remember, our original risky asset was some combination of, tell me, some combination of A and B. Now why should we only select 2 securities? Why not 3? Why not 4? Why not 5, 6? Because in real life correlation between 2 assets is never 1. 1 is a hypothetical scenario. 1 means relationship is linear. But we know in real life it is never like that. So correlation would always be less than 1. And if correlation is less than 1, there is a benefit of reduction in standard deviation. So what if we take all possible assets in the market? So instead of having a combination of A and B, what if we take all possible risky assets in the market, and then that risky asset now will become a market portfolio, and that market portfolio we will add with RFR. So concept is same. This is your CAL. This was that risky asset. This is the risky asset, and we drew a line by adding RFR. Now what we are doing is that risky asset, we are going to define this as, tell me. So risky asset here was combination of A plus B, but now that risky asset we are going to keep that as market portfolio, and the same line, same logic, everything else is same except that composition of risky asset changes. If you draw a curve like this or a graph like this, this line we will call as CML. So this was capital allocation line, and this was capital market line. The only difference is now your risky asset is made of the entire market portfolio. Are we fine here? So write down this, and then again we have to write an important sentence. I mean, yes and no both. Yes and no both. Let's reach to that point after some time. The optimum weight. That's an optimum, that weight which will make the standard deviation lowest. So an hypothetical market portfolio is all the assets in our country. So if we have 5,000 stocks listed, then taking all the 5,000 stocks and the weights would be their market capitalization. Index will have only 50 funds, 100 funds, all the securities. Market portfolio means everything. Okay. Now write down a really important sentence. Every investor will have different CALs What is CL? Capital allocation line. However, all investors will have same CML, because market portfolio would not change. It is same portfolio for everyone. Is it fine? Now this is roughly the work of Harry Markowitz. Okay, and what conclusion are we deriving out of it? If the markets are efficient, then it is not a question of security selection because all securities are correctly priced. An investor would be better off investing into entire market portfolio M and some combination of RFR. And what combination to choose, that would depend on what is the level of risk taking ability of the investor. So these are expected returns. If an investor wants to take less risk, he will be invested in this part of the curve, and this part of the curve would be which type of portfolio? Lending portfolio, because he will have less than 100% into market. This particular point here, this particular point, this is where we have 100% invested in market portfolio, and this point here, these are more risky portfolio with more returns. These are called as borrowing portfolios. Are we fine with this? So write down this again. Now, assuming that you're done, you might have heard this, that Harry Markowitz got a Nobel Award for this entire portfolio management theory. And the interesting thing is that when he was trying to present his PhD research paper, the panel sitting there, they were of the opinion as to whether this subject is fit for doing a research because it was neither economics nor mathematics, isn't it? It's a cross-sectional amalgamation of two subjects where he brought in optimization into portfolio management theory. However, one of the biggest criticism of the theory was the fact that on x-axis, throughout the development of theory, he considered standard deviation as a risk. Now, standard deviation is a measure of total risk, right? How fluctuating the stock returns are over the period of time. Now imagine you have a portfolio worth $100,000 or 100,000 rupees, and you are considering a good stock to invest with that money. Let us say you decided to invest that amount in Tata Motors. Okay. Now tell me, if the Jaguar and Land Rover, which are the popular revenue generating models, if the sales of those models decrease in the market, will the value of your portfolio decrease? Yes, because you are 100% invested into Tata Motors, and if anything happens to Tata Motors, the value of portfolio will decrease. If the union leader feels that let's have fun one more time, and there's again a strike in Tata Motors, will the value decrease? Yes. If there is a earthquake in India, will the value of Tata Motors decrease? Yes. If Central Bank of India comes and says that tomorrow onwards interest rate in our country would be 50% per annum, will the value of Tata Motors decrease? Yes. So the value of Tata Motors could decrease either because of reduction in sales, or because of strike, or because of earthquake, or because of increase in interest rate by central bank. Now, instead of putting your entire money into Tata Motors, what if you decided that let me buy all the possible 4,000 stocks in India? Okay, so whatever is your portfolio, you divided that equally, and now you have purchased 4,000 shares, 4,000 different companies in different proportion. Now, if there is a reduction in sales of Tata Motors, will it affect value of your portfolio significantly? No, it will not, because Tata Motors maybe now is just 1% or less than 1% of your portfolio. If there is a strike in Tata Motors, will it affect value of your portfolio? No. But if there is an earthquake in India, will this affect value of the portfolio? Yes. If there is interest rate increase, will this affect value of portfolio? Yes. So these are the stock specific risk, isn't it? And these risks are coming to you from market risk. So these type of risk that no matter how much you diversify, you would still be exposed. These risks are called as the systematic risk. And the measure of systematic risk is beta, whereas standard deviation was total risk, which was unsystematic risk. So this risk here is called as unsystematic risk. Okay, so total risk is equal to unsystematic risk plus systematic risk. And what Sharpe and Nintner, so again Sharpe, have you seen a Sharpe ratio? So Sharpe and Nintner, even they got Nobel Awards for the subsequent set of work. They said that if unsystematic risk can be diversified away easily, so they made assumption of frictionless markets, no transaction cost. So if some risk that you can diversify away free of cost, then you should not earn a return for that. An investor should be compensated for taking only that part of the risk that cannot be diversified away, which means on x-axis, instead of having standard deviation, we should have beta of the stock. Okay, so write down up to this. Is it done? Now, assuming that you're done, then we are going to have one more line this time, which will again have expected return on y-axis, but instead of having standard deviation, now on x-axis we are going to have beta of the stock, and the line is going to be again a straight line, but this time the line would be called as security market line. So let us repeat the whole story again. Now we'll make a summary of entire thing we've learned so far. You can make a note of it and put this on your wall for a week's time so that you would remember the whole process graphically. Step number 1 was, tell me, minimum variance frontier. So minimum variance frontier. Step number 2 was identification of global minimum variance portfolio and saying that the graph which is, or the line which is above that is efficient frontier. Efficient frontier, EF. Then step number 3, once you have efficient frontier, then plotting the indifference curve of the investors, and that point where it is tangent, then that would be the selection of optimal portfolio. Once you have selected optimal portfolio, in step number 4, so this is your optimal portfolio. Now you are going to combine that optimum portfolio with RFR. So this line would be called as capital allocation line. This is where you are 100% into this risky asset. These were lending portfolios and these were borrowing portfolios. Now all this while we have expected return, standard deviation, return, standard deviation, return, standard deviation, return, standard deviation. Next in the series was a change in assumption, that instead of a combination of A and B, we will have entire market portfolio. So this point you are 100% into market portfolio. This time you were 100% into risky portfolio. Then these are lending portfolios, these are borrowing portfolios. Again return here, standard deviation here. And the last step, we had security market line. This is again expected return, but now on the x-axis we will have beta, which is the measure of systematic risk. And this is the entire life cycle. So put this on a piece of paper, write it quickly. These points, intercepts for all the lines is RFR. This is RFR, this is RFR, this is RFR. Now, two theory questions that could be tested. So let me just remove this. Let's say this is CML and this is SML. Okay. Let's say we have three portfolios. Portfolio A, Portfolio B, Portfolio C. We have three portfolios, Portfolio A, Portfolio B, Portfolio C. If you are on CML, which one of these three portfolios would you like to select? A, B or C? You would like to select A, but what portfolio A is telling you is there exists a portfolio which is smarter than market portfolio, correct? And market portfolio was the highest diversified portfolio. That means there is no other portfolio which is as good as market portfolio. Therefore, in CML, if there is a portfolio which is above this line, then this is an impossible portfolio. You cannot construct a portfolio which is smarter than market, and this is an inefficient portfolio. Is it fine? But when you are on SML, on x-axis you have beta, and on a risk adjusted basis, B gives you the return what is required, A is giving you a return which is more than required, and C is less than required. So A is said to be an undervalued stock or undervalued portfolio. B is correctly valued. So B correctly valued, and C would be overvalued. So remember this, there could be easily a theory question revolving around these points. In CML, A is impossible because you cannot beat the market in terms of efficiency. Assuming all prices are efficient, market portfolio is the smartest portfolio because it gives you the maximum benefit of diversification, and therefore you cannot construct a portfolio which will have lesser standard deviation than the market or same standard deviation as market but have more returns. So here in CML, you are not giving benefit of security selection. Here in SML, it is allowing us for the active portfolio management. It is giving us the benefit of security selection. Done writing this? Okay. Now comparative equation of CAL, CML and SML. I know I'm drawing the same thing again and again. I think it will, once you read your notes, it will be easier for you to do that. Okay, this is, all of these are simple linear regressions. This is CAL, this is CML, this is SML. Returns, 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 standard deviation, beta. This is RFR, this is RFR, this is RFR. Any simple regression, linear regression, the equation is always in the form of a plus bx, where y is the independent variable, a is the intercept, a is called as intercept, and b is called as slope of the line. Okay, so b is the slope and x is the independent variable on the x-axis. So what do we have on y-axis in CL? On y-axis on CL, what do we have? Expected return is equal to expected return is equal to expected return is equal to. What is the intercept A? Intercept A for all the three lines, RFR. So is equal to RFR plus RFR plus RFR plus. Is the slope positive? Is it upward sloping? That means risk increases, return increases. Now what is the slope of CAL? What is the slope? If standard deviation increases, then by how much R will increase? So slope of CAL is return on asset A minus RFR divided by standard deviation of asset A. Have you seen this number earlier? It is the Sharpe ratio. What is the slope of CML? Return on asset M minus RFR divided by standard deviation of M. And what is the slope of SML? Return on asset M minus RFR divided by beta of M. And what is the x-axis value? Standard deviation of portfolio P, standard deviation of portfolio P. If so, this is for P, this is for P, this is for P, and here we will have beta of portfolio P. And we can simplify this equation further. This is Sharpe, this is Sharpe ratio of asset A, this is Sharpe ratio of asset B, Sharpe ratio of asset M because the market portfolio, and when instead of standard deviation if you put beta in the denominator, then that ratio is called trainer. So this is trainer ratio of M, but beta of market is always beta of market is how much? 1. Beta of market is always 1, and therefore we did not write that beta in the denominator, and therefore this value is same as equity risk premium, which is RM minus RF, and therefore this equation is nothing but CAPM, capital asset pricing model. Now, done writing? Okay, take your time. Uh, this thing, trainer, TREYNOR, trainer of market. Trainer is a ratio. Trainer ratio of market. Yes sir. Huh? Minus RFR divided by beta. Beta of market is 1, but for other stocks we can have a different beta. Okay. Now how is beta calculated? So we'll have to do one more line. So we are pretty much reaching towards the end of the topic. Just hold on for some time. Now, how to calculate beta? On x-axis, we are going to put excess return on market, which is RM minus RFR, and on y-axis we are going to put excess return on portfolio or a particular stock, which is calculated as RP minus RFR, and we build a regression out of it. When you build a regression, the intercept of this regression is alpha, and slope of this line is beta of that stock, and this line is called security characteristic line, SCL. Okay, so as far as exams is concerned, there is one curriculum question at the end of the reading which says beta is the slope of which line? SML, CML, SCL. The answer is SCL, security characteristic line. If you are more keen on understanding how beta is calculated, I have a YouTube video 10-12 minutes where we have taken data of a couple of stocks and built regression on Excel, so you can have a look at that. But just know for the timing that this is how beta is calculated. There is also a direct formula for beta calculation. The direct formula is covariance between a particular asset A and market M divided by variance of market M. But in quant we learned that covariance is same as correlation into standard deviation of A into standard deviation of M, and variance is standard deviation of M into standard deviation of M. So we can eliminate standard deviation, and that will give us a new formula, which is correlation into standard deviation of asset A divided by standard deviation of M. So these are the two formulas you need to know. First formula, second formula, and both formulas will get you the same answer. Done. Next thing now, do you want to take a break? We just took a break, right? So 5-10 minutes back. Yeah. So now what I'm doing next, you're going to do this on the actual exams. No, if I say this, I'll be violating CFA ethics. So what I'm doing next, there's a high probability that you're seeing this on the actual exam. So be focused. And if you understand how I do it here, it is going to save you tremendous amount of time when you try to revise this topic. Okay, the method is slightly different than how it is presented in the notes. So heading would be 4 possible types of questions on CAL and CML. There are only four possible questions that can be tested, and those are integrated with each other. Since the equation of CAL and CML is same, the same method works for them. Okay, so what kind of questions are we looking at? Let us say you would be given data like this. Return on market 20%, risk-free rate of return 8%, standard deviation of market 4%. Okay, this is the data given to us. Now we have a CML line, and the first question, if a client is willing to take standard deviation of 3%, what should be his expected return? Okay. Now I will show you how it is solved in the notes and then a shortcut of solving this. How they've done it in the notes is they've just plotted the formula. They've said RFR plus RM minus RFR divided by standard deviation of M into standard deviation of P. So RFR is how much? 8 plus RM minus RFR numerator would be 12. This is 4 into standard deviation that client is willing to take 3. So this would give us 17%. Okay, this is how they propose this to be solved. Is it fine? Now there is an alternative way of dealing with this. Okay, it's essentially the same equation but easier thought process. How you would think is, this is the line. Okay, I have a shortcut to this. So this is the line, and this intercept is the RFR. That means an investor who is taking zero risk is also going to earn RFR. So first thing that you do is calculate a Sharpe ratio. You will say 20 minus 8 divided by 4. Sharpe ratio is how much? 3. Sharpe ratio 3, interpretation is, for one risk we will get 3 extra returns. For one risk we will get 3 extra returns. Now client has taken, so market has taken risk of 4 and total returns of the markets are 20. If the client is willing to take risk of 3, then it will earn 3 less than 20. One risk is equal to 3 return. If client is taking risk of 3, that means it is taking one risk lesser than the market. Do you agree? If one risk is lesser than the market, then client should earn 3% return lesser. So for a risk of 3, the return that client is expecting to earn is 17%. If the client wants to take risk of 2, then 3 will reduce further, then 14%. If client wants to take risk of 1, then returns would be, if client wants to take risk of 0, returns would be 8%. If he's taking risk of 4, then he's 100% into market. If he's taking risk of 5, his returns would be 23, this would be 26, this would be 29, so on and so forth. Easy? So write down up to this. So first type of question is they will give you standard deviation, you will have to calculate expected return. Second type of question. Now they will say the other way around. Done? They will say the other way around, that client wants to earn an expected return of 21.5%. What should be the risk? They will give you returns, you would be required to calculate risk. Again, the thought process is going to be exactly same. You will say Sharpe ratio is how much? 3. That means 1 risk is equal to 3 extra returns. Now compared to 20, client wants to earn 21.5. So he wants an extra return of 1.5. So he will have to take extra risk of 0.5, which means the standard deviation is going to be 4.5. Are you following this? If the client wanted to earn a return of 23%, then extra risk of 1. So then that would be 5%. If client wanted to earn 26%, then 6%. If client was okay with 17%, then 3%. If client was okay with 14%, then risk 2%. So same calculations like the earlier one. Is it fine? So write down this. Third type of question. Now they will say a client is willing to take standard deviation of 2%. What should be the portfolio allocation? That means what should be the weights? This is a third category of question. So how will we solve this? We will say standard deviation of the portfolio is equal to weight of risky asset into standard deviation of market. Do you agree with this? Have you seen this formula earlier? Yes. Why? Because in your standard weight 1, weight 2 square formula, the second and third term becomes 0. Fine. Now client wants to take a risk of 2%. So we can just revise this formula and we can say weight of risky asset is equal to standard deviation of portfolio P divided by standard deviation of market. So in this case 2 divided by 4, allocation is going to be of 50% in risky asset. Now if client wanted to take standard deviation of 1, then weight would be 25%. Standard deviation 2, weight would be 50%. 3 would be 75%. At 4 he is 100% into market. At 5 it is now a borrowing portfolio. At 6, 150%. We just keep on doing the proportionate calculations. Fourth and last type of question. if client wants to earn an expected return of 17%, what should be the weight? And this question is almost same as integration of question number 2 and 3 together. Okay, so then how would you deal with this? Now, if expected return is 17%, that means 3% lesser. So therefore standard deviation should be how much? 3. And once we know standard deviation, then weight in risky asset is simply 75%. That means if you've been given expected return, find out standard deviation, then find out weight.